You probably know someone like this. They go to bed at midnight, they're up at 4, no alarm, no groaning, no 3 rounds of snooze. They just wake up, ready, actually ready. And then they spend the rest of the day being completely annoyingly functional while you're on your second coffee trying to remember your own name. And you've always assumed one of two things: either they're lying, quietly running on fumes and too proud to admit it, or there's some kind of self punishing productivity obsessive who trained themselves into this through sheer willpower and a cold shower habit. What if neither of those is true? What if, for a small group of people, a genuinely tiny group, the normal rules of human sleep simply don't apply the same way? Not because they hacked it, not because they're tougher than you, but because they were born with a different biological architecture, a different set of instructions in their DNA that makes their sleeping brain work at an efficiency the rest of us will never reach no matter what we do. That's not a motivational claim, that's genetics. And the science behind it is stranger, deeper, and more humbling than almost anything else we've found inside the biology of sleep. Let's start with what sleep is actually doing, because before you can understand why some people need less of it, you need to understand what it costs the rest of us to skip it. Every hour you're awake, your brain is running a quiet chemical clock. It's called adenosine. It's a byproduct of neural activity. Your neurons burn energy to think, to feel, to process everything you experience, and adenosine is what's left behind. It accumulates, slowly, steadily, hour by hour. It builds up in the spaces between your brain cells, binding to receptors that gradually make you feel heavier, slower, less sharp. This is sleep pressure, the biological weight of wakefulness. By the time you've been awake for 16 hours, adenosine levels in your brain are high enough that your body is essentially declaring an emergency. Reaction time slows, decision making degrades, emotional regulation, your ability to not snap at someone for breathing too loudly, starts to fail. Your brain isn't being dramatic, it's running out of runway. And the only thing that clears adenosine is sleep. This is worth sitting with for a moment. Caffeine doesn't clear adenosine. It blocks the receptors that detect it, which is why coffee makes you feel alert even when the pressure is still building underneath. The moment the caffeine wears off, all that accumulated adenosine hits at once. That's the crash. That's why the second coffee feels less effective than the first. The debt is still there, it's just being hidden. Sleep clears the debt. Specifically, slow wave sleep, the deepest stage of NREM sleep, is where adenosine gets cleared most aggressively. Your glymphatic system, a kind of waste clearance network in the brain, becomes dramatically more active during deep sleep, flushing out accumulated metabolic waste, including adenosine, at a rate that simply cannot happen while you're conscious. This is the contract: stay awake, build pressure, sleep, clear it. Miss sleep, carry the debt forward. Miss enough sleep for long enough, and the deficits compound in ways that don't fully reverse even after you catch up. That's the deal for almost every human being on the planet. Almost. In 2009, a research team at the University of California, San Francisco, led by neurologist Yinghui Fu, was studying sleep duration in families, specifically looking for genetic patterns in people whose natural sleep was unusually short. Not people who set early alarms, not people trying to sleep less. People who simply woke up naturally after a fraction of what the rest of us need and were genuinely, measurably fine. They found a family, a mother and her adult daughter, both of whom consistently slept somewhere between 6 and 6.5 hours a night. No alarm, no grogginess, no performance deficit. They went to bed at a normal hour and woke up before the sun with what they described as effortless readiness. The team ran genetic analysis, and buried inside a gene called DEC2, they found a mutation, a single letter change in the genetic code, technically called a point mutation, that neither the mother nor the daughter shared with the other members of their family who slept normally. The carriers averaged 6.25 hours of sleep per night. Their family members without the mutation averaged 8.06 hours. The difference was consistent, involuntary, and tied to a single genetic variant. This was the first time science had found direct genetic proof that natural short sleep was real. Not trained, not forced, not performed, real. To confirm it wasn't coincidence, the team introduced the same mutation into mice. The mice with the mutation slept less. They showed no behavioral impairment. Their sleep was, by measurable biological standards, more efficient. They were getting the same restorative work done in less time. Let that sit for a second. Not less sleep with consequences, less sleep with the same outcome. The biology was running faster, completing the same maintenance in a shorter window, like a car that needs half as many miles to the tank and somehow runs just as cleanly. And here is where it gets even stranger. Because this wasn't just an interesting data point about sleep duration, it was a window into something much deeper, into the actual machinery that controls how long a human being needs to be unconscious for their brain to function at full capacity. So, what is DEC2 actually doing? DEC2 is a gene that produces a protein, a transcription factor that acts as a kind of molecular brake on orexin. Orexin, if you haven't heard of it, you're about to, because it's one of the most important molecules in the story of human wakefulness. Orexin is a neuropeptide, a signaling chemical produced in a small cluster of neurons in the hypothalamus, the region of the brain that acts as the master regulator of sleep and wakefulness. And its job, in the most direct terms, is to keep you awake, to keep the brain's arousal systems firing, to maintain the alert, conscious state that lets you function in the world. Under normal circumstances, DEC2 acts as a governor on orexin production. It suppresses it, keeps it in check, prevents the wakefulness signal from running too hot. When DEC2 is mutated, when that single letter in the genetic code is changed, the suppression weakens. The brake on orexin becomes less effective, and so the brain produces more orexin more efficiently for longer. What this means in practice is extraordinary. In a normal brain, as sleep pressure builds through the day, the orexin system eventually loses ground to the rising tide of adenosine. The alertness signal weakens, sleep wins. The brain goes offline to clear the debt. This takes time. A full sleep cycle takes roughly 90 minutes, and most people need 4 to 6 full cycles to fully clear the previous day's pressure and complete all the biological maintenance that sleep is responsible for. In a short sleep brain, the orexin system is running at a different efficiency. The brain gets more alertness per unit of sleep, more restorative work completed per hour. It's not that the brain is skipping the maintenance, it's completing the same maintenance faster with higher throughput. The engine runs at a different clock speed. This is why short sleepers wake up after 6 hours feeling what you feel after 8. Their biology is simply more efficient at the core task. Now, here's where the story adds its second layer, because DEC 2 was just the beginning. Since 2009, researchers have identified at least 2 more genes associated with natural short sleep. In 2019, Fu's team identified a mutation in a gene called ADRB1, the beta 1 adrenergic receptor gene. This gene sits in a completely different part of the sleep machinery. Where DEC2 affects the orexin pathway, the wakefulness signal, ADRB1 affects a cluster of neurons in the dorsal pons, a region of the brainstem directly involved in REM sleep regulation and the transition between sleep stages. Carriers of this mutation showed shorter sleep duration and, critically, more activity in those neurons during NREM sleep, suggesting their brains were extracting more restorative work from each sleep stage, not just sleeping less in total. Then there's SIK3, a more recently studied gene involved in regulating NREM sleep pressure. Essentially, how much deep, slow wave sleep your body demands before it considers the night's work complete. Mutations in SIK3 appear to reduce that demand. Less NREM sleep required. The body hits its maintenance quota sooner. The night ends earlier. 3 genes, 3 different levers, 3 different points in the sleep system, where a rare mutation can make the whole machine run faster. This is not one lucky genetic quirk. This is a small family of mutations, each targeting a different mechanism inside the biology of sleep, all converging on the same outcome: a brain that needs fundamentally less unconscious time to accomplish the same restorative goals. And every single one of them is involuntary. You either have them or you don't. There is no pill, there is no protocol, there is no biohack. These mutations are present from birth, expressed in the architecture of the brain itself, and there is currently no known way to replicate their effects artificially. If you're starting to wonder, even quietly, even just a little, whether maybe you might have one of these, whether maybe that's why you sometimes feel okay on 6 hours, we're going to come to that. And the answer is probably not what you're hoping for. Here's the uncomfortable truth: most people who sleep 5 or 6 hours a night are not natural short sleepers, not even close. The mutations we've been talking about are extraordinarily rare. We're not talking about one person in 10 or one in 100. We're talking about a vanishingly small fraction of the human population, a biological edge case, not a widespread variant. The overwhelming majority of humans have a sleep need of somewhere between 7 and 9 hours, and that need is not optional, and it does not negotiate. What's actually happening in the brain of someone sleeping 5 hours by choice, or necessity, or social pressure, or just the grinding pace of modern life is something very different from what's happening in a short sleeper's brain. Remember adenosine, that slow building chemical pressure of wakefulness? In a sleep deprived brain, adenosine clearance is incomplete. 5 hours of sleep does not fully clear the adenosine load built up over 16 to 17 hours of wakefulness for a normal human brain. The glymphatic system doesn't finish the job. The debt carries forward. And here's the part that makes this genuinely alarming: sleep deprivation impairs your ability to accurately assess your own sleep deprivation. This has been shown in controlled lab studies. When people are restricted to 6 hours of sleep per night over 2 weeks, their performance on cognitive tests steadily deteriorates. Reaction time, working memory, decision making all decline measurably and progressively. But when those same people are asked to rate how sleepy they feel, their self ratings plateau after a few days. They stop feeling as bad as they actually are. They adapt to the feeling of impairment. They mistake chronic tiredness for their new normal. This is the cruel trick of sleep debt. You stop feeling how tired you are. You start to think you're fine. You start to think maybe you're just one of those people who doesn't need much sleep. You almost certainly aren't. A genuine natural short sleeper has no debt to carry. Their adenosine is fully cleared in 6 hours because their brain's efficiency means 6 hours is enough. They don't feel like they're powering through. They don't need caffeine to maintain function. They don't crash on weekends. They don't feel restored by sleeping in because they were never depleted. If you sleep 5 hours on weekdays and then sleep 10 hours on Saturday, you are not a short sleeper. You're a person in debt who finally got a chance to pay it back. This matters because there's a seductive narrative in modern productivity culture, particularly in certain tech and business circles, about sleeping less as a badge of efficiency. Leaders who claim to run on 4 hours, the hustle gospel that says sleep is for the weak or for people without enough ambition. And while some of those people may genuinely be rare short sleepers, we simply don't know because none of them have undergone the genetic and clinical analysis required to confirm it. The vast majority of people who model themselves on that narrative are running on a debt that compounds quietly and pays out in ways that don't show up immediately. Not in the next day, sometimes not in the next year, but in cardiovascular risk, in immune function, in cognitive trajectory over decades. The science is consistent and it is not gentle. This is not meant to frighten you, it's meant to make the distinction clear. Natural short sleep is a biological reality. Sleep deprivation is a different biological reality. And confusing the two, telling yourself you're the exception when the odds are overwhelmingly against it, is one of the most common and quietly costly mistakes people make about their own health. The short sleepers aren't showing you what's possible with enough willpower. They're showing you how deep and how precise the biology of sleep actually is. Deep enough to have rare exceptions engineered right into the genetic code. Precise enough that those exceptions work differently, mechanistically, at the molecular level, not just behaviorally. So, what does all of this actually mean for you? It means the person you know who swears they're fine on 4 hours might be telling the truth, not because they're stronger than you, not because they trained themselves, but because somewhere in their genome, a single letter of genetic code is written differently than yours, and that difference cascades through their orexin system, their adenosine clearance, their NREM architecture in ways that make 6 hours genuinely sufficient. And it means that if you don't have that variant, which statistically you almost certainly don't, the most honest and valuable thing you can do is stop competing with them. Your sleep need is real, it is biological, it is written into you just as surely as their shorter need is written into them. The difference is that their exception gets celebrated in boardrooms and podcast interviews, while your requirement gets quietly treated like a weakness. It isn't. It's just how the system works for the vast majority of human beings who have ever lived. Sleep is not a default state. It is not your brain doing nothing. It is the most complex maintenance operation your body runs, and it runs it on a schedule that is, for most of us, non negotiable. The fact that a tiny number of people have a rare mutation that lets them run that operation faster is remarkable science, but it is not a roadmap. It is not an invitation. It is, if anything, evidence of how seriously evolution has taken sleep. Seriously enough to build an intricate molecular system to regulate it, and seriously enough that even the rare exceptions who need less of it still need a version of it. Their brains don't skip sleep, they just run it differently. Understanding that, really sitting with it, might be the most useful thing you take from this. You are not broken for needing 8 hours. You are not weak for feeling the crash after 5. You are a human being with a biology that has been shaped over millions of years to require something that modern life treats as optional. It isn't optional. And the fact that you now know exactly why, down to the gene, down to the molecule, means you're in a better position than most people to actually honor it. If you've ever wondered whether the way you sleep is normal, whether your nights are working the way they should, or whether the exhaustion you carry is just the price of being alive, there's a guide called the Insomnia Reset that's worth your time. It won't change your genes, but it will help you get the most out of the sleep system you actually have. Sleep well, you've earned it.